Now? When?
Right now?
When?
Go ahead.
Hi, I am Jonah Brandenburg. And I thank you all for being here. I'll be reviewing the article titled Head Trip. The article discusses something called Gedanken experiments. What are they? Gedanken experiment is German for thought experiment. The three benefits of it are: it doesn't cost anything, you have unlimited resources, and a very low risk of injury. The only danger is getting tired of thinking of them. Yeah. But what do critics say about them? They say there's no data to support them, so you can't test them in the actual experiment. The first thought experiment discussed is also the most famous one, the windowless elevator. Einstein actually created it at age 28. So what was the experiment? It says that Einstein thought that if he was in an elevator in the presence of gravity just staying there, feel no different as if he was accelerating through space. And that one experiment led to the principle of equivalence, which is basically what I just said. Elevator and gravity not moving, same as elevator accelerating in space. So, and it also led to general relativity in space-time. The second thought experiment discussed, it's called spooky action at a distance, or spooky action for short. So, to describe the experiment, I have this friend way up in the Andromeda galaxy. Let's call him Andromeda Andy, okay? So, he's going to catch the particle that I'm going to throw up there. So, I have this particle on my finger. I'll throw it up there. And so now he caught it up there. So, if I measure this particle, I know his part, and if this particle is measured to spin up, we instantaneously know that that one is opposite to spin down. Let's talk about entanglement and superposition before we get into any more details. Entanglement means that two particles can have undefined spins, and then you measure one and immediately know they'll spin of the other. Kind of crazy. Superposition superposition is another quantum property that says that any particle can have spin up and spin down at the same time. There's another concept called the Heisenberg uncertainty principle, which means the more you know of one, the less you know of another. The two quantum states that's mostly about are position and momentum. Einstein called it spooky action because it implies faster than light communication. He also thought the uncertainty principle was nonsense because he likes things to be supported with data, and there's nothing there. So he met up with his colleagues Podolsky and Rosen. They're the last names. The last names. And they created the EPR experiment thought. The EPR thought experiment. So what was the experiment? The experiment said that if there's this parent particle and outcome it's unstable and two daughter particles come out of it, they must have opposite spins. We'll actually demonstrate that to you after I'm done reviewing it. So Einstein concluding that there's encoded data in the particles. It took almost 30 years from then until 1964 to disprove hidden variables. John Bell is the one who did that. He found slightly different information. So Einstein was wrong and right. The last thought experiment discussed is called Alice and Bob. I like to call it Alice and Bob and Charlie too, because later they throw in Charlie. So before I discuss it, I need to explain the black hole information paradox. So let's say you have this book and you burn it up. Quantum mechanics is saying you can take all the info, put it back together again into sort of a book, sort of. Well, general relativity says that if you put something into a black hole, you're never getting that something out again in any form. So, general relativity says it's not reversible, and quantum mechanics says it is reversible. 1993, Susskind and his colleagues developed this thought experiment to try to reconcile general relativity and quantum mechanics. So what was the experiment? The theory says that the radiation emitted... Well, first I need to talk about Alice and Bob. Say Alice jumps into a black hole with her entangled particle. The particle's entangled with Bob's. And the experiment says that it's not violating monogamy, which is only two things can be entangled, not a third. Is actually that emitted radiation that comes out of a black hole, when it swallows something, then radiation comes out. It says the radiation is actually Alice in her particle. So, I already explained monogamy. Critics are saying, so does the experiment violate monogamy? And does it also violate principal equivalence? Because Charlie can't tell the difference whether or not he falls in or not. But it also implies a firewall, so does it violate general relativity, which says time slows down for you, more gravity. The intriguing points to me that I took from this article is that Einstein was only 28 when he developed general relativity in space-time. So I bet there's one person here that is not far away from becoming 28. And I bet that person could come up with a famous theory at age 28. So you don't, it's not long. Niels Bohr said, if Einstein can disprove uncertainty, how can Einstein not disprove it? The third intriguing point is that there's a possibility of a firewall going around the black hole, so it burns anybody up before they even reach the event horizon. The applications that I took out of this article, that Einstein's thought experiments have changed all of physics. And when we think about it, if you can control the opposite random, has anyone seen the Veritasium video on spooky action at a distance? You have?
Explain.
He called it the opposite random, because when you think of opposite, you think predictable, but you don't know which one's spin up or spin down, so the opposite random. If you can understand that. If someone in this room can reconcile quantum mechanics and general relativity, because remember that complementarity is just an attempt. So if someone in here could actually reconcile them and actually be proven, it would probably win a Nobel Prize. That could be one of you in this room. I actually. So if time slows to my questions are: if time slows to a stop in a black hole, will a person falling into one ever know when they're spaghettified? The second question is, Einstein was wrong about the hidden variables thing, but right on special relativity. So he's both wrong and right. So the question is he in a superposition state? He's both right and wrong, so. Questions? Yes?
How old is he?
9.
Yeah.
All I want to know is, what were you doing when you were?
Yeah, that's how old I was. That person didn't play that.
Hey, Jonah, you did a really good job with that. I'm really proud of you. Now, just to make it clear, Jonah has actually been sitting in on classes at TU by offer of the president of the university has allowed him to sit in on classes. And so this is not the first class he's taken. He's also taken astronomy, where he got an A. Oh, I'm sorry, I'm not supposed to tell these kind of private things. So anyway.
Sorry.
Anyway, Jonah's doing a real nice job, and I was glad to have him up here. So we're going to open this in just a second. Just hold your question here. I just want to point out one thing. You know, I've always heard about Einstein's Gedanken